In this video we will pay attention to this function over here. This is the sine hyperbolic function. So it's e to the x minus e to the minus x over 2. What is the domain of this function? Is the whole set of real numbers. So this is the domain of this function. Now let's see if we can find we will want to try to find the inverse of this function. So y is e to the x minus e to the minus x over 2. In order to find the inverse function, we need to solve with respect to x. So we will rearrange a little bit this equality. E to the x minus e to the minus x is equal to 2 times y. So we move the terms to the left hand side, all of them, and we obtain this equal to 0. We multiply with exponential function. To obtain this equation. Set omega to be e to the power of x. So this can be reformulated in this following way: omega squared minus 2 times y times omega minus 1 equal to 0. Of course, this is a quadratic polynomial, and the discriminant is is 2y squared minus 4 times minus 1. So it's 4y squared plus 4. We take common factor 4. So it's 4 times y squared plus 1. So this is a polynomial of degree 2 and the variable is omega. So the two roots, let's say omega plus is minus 2y. So it's plus 2y plus the square root of the discriminant, 2 times square root y squared plus 1 over 2. So omega plus is y plus square root y squared plus 1. Omega minus is 2y minus 2 square root y squared plus 1 over 2. So omega minus is y minus square root y squared plus 1. Now in order to find the inverse function, we have to pay attention that omega is e to the power of x, and from these two we have to neglect one of the relations. So let's see the first one. So we get back to the original exponential. E to the x is y plus square root y squared plus 1. So e to the x is a strictly positive function, so this should be strictly positive. So we take the natural logarithm of y plus square root y squared plus 1. So from here, if we change these variables, the inverse function is natural logarithm of x plus square root of x squared plus 1. And of course the let's see the domain of the inverse is the set of real numbers, the whole set of real numbers. So it's minus infinity infinity. But now probably we have to neglect the other one, so let's make a test. Omega minus is e to the power of x, which is y minus square root of y squared plus 1. So this should be a strictly positive quantity, but let's test. Does this hold? we can rewrite this as this goes to the other side, to the right hand side. So this is, we write it like this. So y squared is greater than y squared plus 1, and this gives that 0 is greater than 1, which is a contradiction. Therefore, we neglect, of course, this option. So our inverse function is this one, and we know, of course, that the domain of this function is the range of the inverse. So the range of the inverse is R, the set of real numbers, and we know that the domain of the inverse is the range of the function f. So the range of function f is the whole set of real numbers. So it's this one. So finally we can write it. This usually appears as arc arc sine hyperbolic of x, or sine hyperbolic minus 1 to the minus 1 of x, the inverse function. Of course, we write again the domain, and we write the range of f of the inverse, which is this one. I hope that you enjoyed the video, and until the next time, I hope you are doing well.